Okay, well, we have a few things, to talk about today. The first one is, since I'm already on this page or, having this program running, I'll just, start with this one. This is called Scratch, which is a programming, it's what we call an IDE or an integrated development environment. Except in this case, it really is a toy, okay? It is intended as a toy, but it's educational. And it is also particularly related to this class because we are trying to learn how to write programs. In this class, my objective is to make sure that you guys understand the mechanisms of doing things. What is a conditional statement? What is a loop? What is a subroutine? How do you pass parameters? How do you return a value? So we are only talking about individual components, but for people who want to put a program together and actually see it run, pseudocode is not the best option because you have to emulate the execution of the entire program, which can get kind of boring at some point, especially for people who know that stuff already, right? So for people who already know the basic concepts of loops and whatnot, and want to just put something together and see it work, this is one of the best options out there. One, it is free. Okay, you cannot beat free. And two, it is completely graphical. There's no syntax to learn. Okay, now Python is an easy programming language to learn, but even with Python, you have to learn the syntax. Okay, you have to know what keyword to use for a conditional statement. What do you use a colon at the end of a line or not, and so on and so forth. This one is completely syntax-less. Okay, well, that's actually a lie. The syntax is actually built in to the graphical interface. So I'll kind of show you what I mean by that. Let me just get rid of this file, starting with a new one, not save the current one. Okay, so first of all, I want to describe the different portions of the screen. This is what they call a stage. Okay, this is where the action happens. And under the stage is a control area where you can control. I'm writing a script for, okay? Are you writing a script for the stage? The stage itself can do things. Or am I writing a script for sprite 1 in this case? Because I only have one sprite by default. It doesn't mean that you cannot have additional sprites. If you click one of these buttons here, you can create an additional sprite if you want to. All sprites of the same Scratch program, they all run at the same time. Okay, so this is a great way to look at parallel programming because you now have multiple threads running at the same time, each one controlling exactly one sprite. If I have multiple sprites, I can click the sprite to control which one, or I'm writing a program for which sprite on the screen. Or I can click stage, and it changes to the program of the stage. At this point, there's no program, so regardless of which one I click, there's nothing here in the middle part of the entire screen. On the left-hand side, we have all the building blocks. In other words, these are the individual items that you can put into a program. They are all separated into different categories. The first one is motion. In other words, what can I make the sprite do? I can make it move, I can make it turn, I can make it point in a certain direction, I can make it point to a certain thing. Okay, that's kind of interesting because you can, when you have multiple sprites, you can make one sprite to point to another sprite. Now that I don't have another sprite, I can make it point to the mouse pointer instead. You can make it, teleport to a particular location using XY notation. You can make it go to a particular object, like where your mouse pointer is. You can make it glide to a particular location. You can change the X by a certain amount, which means it's only moving horizontally. You can make it change by the Y, which means it's moving only vertically, and so on and so forth. So there are motions you can do. You can change the look of the sprite. You can change the costume. There are two costumes for this little cat, which basically make it possible to emulate an animation of the cat walking. But you can create your own bitmaps. In other words, when you create, or you can modify Sprite 1 if you want to. For those of you who are really good with Photoshop and stuff like that, you can make your own sprites, okay, and make different costumes for your sprite. So you can, with animation, you can make your sprite look like a spider walking. Okay, you can make it emulate, the animation of an explosion if you want to. Okay, so there are lots of interesting things you can do with just the costume. Excuse me. You can make a sprite interact with the user. You can make it say hello, in this case for 2 seconds. You can make it create a thought bubble for 2 seconds, just like that. You can also make it change the color. You can change the size of the sprite. You can reset it back to a certain size in terms of percentage of the original size. You can show the sprite which is shown at this point already. You can also hide the sprite. The sprite is still there. It is still on the stage. It is just not visible at this point. You can control the sound. You can make it go. Okay. You can play a drum. You can play a note. Okay. So there are many things you can do. It's really multimedia based. You can have a pen. You can have the sprite drag a pen behind it. In other words, then you can make the sprite draw a particular pattern on the screen. Okay, you can make it draw a triangle, a hexagon, a square, a rectangle, or just make it go random. Okay. But in this class, the most important part is control. Okay. When you look at the blocks of control, this one is nothing more than the beginning of the entire program. Okay. But if you look at the other blocks, we have something that's kind of interesting. We have, let me scroll down to that part. First of all, we have conditional statements. We have the if block without the then, and then we have the if-else block. And that corresponds to our if, else, and if construct. We also have repeat until. Okay, repeat until is pretty much the same thing, except in this case, I think it checks the condition first. Okay, so it's a pre-checking loop, but it is specifying the exit condition instead of the stay in loop condition. Okay, and you can also have variables, just like we have variables in pseudocode. You can create, variables in this case. Are there any questions at this point? Yep.
So it's a variable. What can you actually accomplish with this? The cat can just move around the screen, and what can you actually accomplish with the program?
Well, you can use a variable to keep track of the score if you're running a game. Okay. A variable is just a variable. How you want to use the variable depends on the program that you're writing. What you want the program to do. The most complicated program I have created with Scratch is Hangman. Okay. Now, if you think about Hangman, it doesn't seem like a very complicated kind of game, but that's only because we, people, can scan through, a word for letters and match everything, easily. When you try to specify in a programming environment, it is not quite as easy. Okay, it can be done, just not as easy. I'll go ahead and just write a very simple program, the find max program. That same good, boring program that we have been writing for so long. I start with, when green flag clicked. Okay, it starts the execution of the entire program. Basically, when I click this little green flag here, it will start the execution of the program. And then the first thing I want to do is to use sensing here, and I will ask a question. What is your name? Well, I don't really care about the name. Instead, I want to say input a number. Okay. And then what I do is I want to store that into a variable because I want the program to ask me to enter 2 numbers. It will figure out which number is the maximum, which one is the larger one, and then it will report back to me and say the maximum of these 2 is blah. Okay, that's what I wanted to do. So in order to do that, I have to use variables. Okay, so I'll go ahead and make a variable. We'll just call it x. In this case, I will set x to whatever the end user inputs, which means I have to go back to sensing and drag the answer to here. Okay? I'm not sure how many people can see this, especially people in the back. It says here set x, which is the name of my variable, to answer. The answer to what? The answer to the question that I just asked. Okay? In other words, this is a quick and easy way for Scratch to take the content of a text box and put it into a variable. It doesn't have a sense of type. In other words, I can type in anything, and we just put it into the variable, that we call x here. And then we can make it ask another question. Okay, here we go. And we can ask it to input another number and wait. And this time I need another variable. We'll call it y. Make a new variable, call it y. And here we set y to the answer of the previous question. Go back to sensing and drag answer to this block here. In other words, there's nothing to type except for the prompts. The entire program is put together by dragging and dropping blocks from the left-hand side. Are we doing okay so far with this concept? Okay. It doesn't use the pseudocode notation that we use in this class, but I'm hoping that you guys can actually map what we use in this class to the constructs in Scratch. And then what we can do is we can use a conditional statement. So we go to control, we go to if-else, drag the if-else block here, and now I have to specify the condition. If x is greater than y, then something, else do something else. The comparison is under operators. You can see that there's a greater than comparator here. Now, if you just hold down the mouse button over a construct and wait a little bit, it pops up a help bubble, and if you click on the bubble, it will explain what that particular construct is and how to use it. The other thing you want to kind of see at this point is the constructs on the left-hand side, they come in different shapes. We have conjunction, disjunction, and negation. These all have a hexagon shape, pointed edges. We also have mod. We have the calculations, addition, subtraction, and whatnot. They all end up with round edges. But when you look at the slot here of a conditional statement, it has a shape of a hexagon. In other words, the shape of these objects have to match the shape of the slot that you're going to put it into. In this case, the hexagon means it's a Boolean. Okay? It has to return a value of true or false. That's why the conjunction, disjunction, negation, and also the comparison operators, they are all hexagons because they all return a Boolean value. Whereas addition, subtraction, multiplication, and division up here, they all have a round edge because they only return a numerical value. So what we need here is to put in a comparison operator, and then I can decide, what am I comparing with what else. Both of those are variables that I have defined. I would use x here. I would use y over here. If x is greater than y, then we do something. Otherwise, we do something else. We can make a new variable z. And then inside the conditional statement, I can use the set block again, except I have to change this part here. Set z to x if x is greater than y. And over here, I specify set z to y if x is not greater than y. So this way, z is the maximum of the two variables. When this is all done, z would have the maximum, and I can ask the sprite to reflect the answer. I can use a speech bubble to reflect the answer. And the way to do it is to go to looks again, and we can say something for whatever long. We can specify 10 seconds here so it doesn't go away too quickly. And whatever I want to say is not hello. I wanted to say a certain